The second group. Who's the narrator in this group?
We each have a part. I'm going to go ahead and start it. We are the Krebs cycle. The Krebs cycle is the second step in cellular respiration. It actually takes place in the matrix of the mitochondria. We must have oxygen to take place, and it is also called the citric acid cycle because most of the intermediates in the steps are organic acids or carboxylic acids. The goal of the Krebs cycle is to generate ATP, and it's a series of redox reactions or coupled reactions. I am acetyl-CoA. I actually am also considered the preparatory reaction. Oxidation of glucose produces pyruvate. This is me, pyruvate. Molecules which diffuse from the cytosol into the mitochondria. Pyruvate itself does not enter the citric acid cycle. A reaction occurs which removes a carbon atom and releases it as carbon dioxide. Coenzyme A joins with 2 carbon, forming acetyl-CoA. One molecule of acetyl-CoA enters the cycle. Then the CoA drafts away and bind to go away, and it'll bind with more pyruvates later, and it leaves a carbon or 2 carbon to bind with my friend here, who is acting as oxaloacetate.
Oxaloacetate, that is me. I'm a 4 carbon, and I gained 2 carbon, which makes me a 6 carbon that I will now transfer over to citrate.
Okay. And I am citrate. I am a 6 carbon compound, and in my process, NAD plus reduces to NADH, and that gets released. And then and also, I lose 1 carbon, and it turns into, the carbon that is released is carbon dioxide, and then it turns to a 5, which is ketoglutarate.
Okay, I'm ketoglutarate. I have 5 carbons. The substrates are oxidized, so my NAD plus turns into NADH and gets released. And I also release carbon dioxide, so I release 1 carbon. I'm not going to do this. Sorry. Okay. And I also produce ATP and release it. So then my 4 carbon goes to succinate.
I am succinate. I am 4 carbons. I reduce FAD to FADH2. I release it. Okay, sorry, carbon. Okay, I release it, and then I transfer to fumarate.
I'm fumarate, 4 carbon compound. A substrate is oxidized, and NAD is reduced to NADH, and then released, and then I transfer my compound back into the cycle.
And then because the Krebs cycle is actually 2 rotations, we start all over again. My CoA that had gone back picked up more, and I come back to this cycle, and we do it all over again. It goes for 2 carbons. I should have done that, should I?
So the rings are representing what? Since we all saw the glowing
Carbon, E carbon.
The glowing rings.
The
blue
glowing
ones are
rings are
carbon.
your carbons, right?
Right.
And what is that little flash thing? The big piece that's flashing?
NAD.
This is the NAD plus, and then it reduces to NADH.
I'm just gonna let it open the light side. I think we can get better pictures. I don't know if
Oh,
it's
I've got my flash.
with the video. I don't know what's supposed to.
It's better for the video with the light on,
Get a little bit of.
because the light on the camera.
So in mine,
So you can show them that the pink are your NAD, NADHs. So, how many carbons did you move around? Because it seemed like you released in the process.
I release 1 carbon.
I released 1.
And I think, Stacy, you had
In the initial, yeah.
initial. So there were 3 carbons given away. How many NADHs or FADHs?
1 FADH.
And which one was that?
That was succinate.
That was the glow succinate, which was the substrate. And what about the NADH? How many of those?
Those were 3.
2.
There's 3, I'm sorry.
3. There were 3, right? And what is that orange ring
This
that you
is
have?
ATP.
And how many was that?
Just 1.
Just 1, right? So what happens to all these pieces that are coming out?
They are released and they're used later in the next cycle, the electron transfer cycle.
So, all right, anybody has any questions so far? Yeah.
The glow sticks was good.
The glow stick was a good idea, yeah.
Yeah.
But you didn't tell us where this all takes place, within which region?
The matrix of the mitochondria.
Oh, you did, okay, I received that, okay. So, thank you.
Thanks.